Okay, guys, today let's talk about chirality and how to determine whether a molecule is R or S. Now, a chiral carbon is merely a carbon that is connected to four different things. To determine whether a molecule is R or S, you first need to assign priority groups 1 through 4 based on atomic weight, where your heaviest atom based on atomic weight will be your number 1, and your lightest group based on atomic weight will be your number 4. That 4 group is almost always going to be a hydrogen. You must have your number 1 group coming at you on a wedge and your number 4 group going away from you on a dash. If they aren't initially in this configuration, you must perform 2 swaps, no more and no less, to get number 1 on a wedge and number 4 on a dash to be able to solve. Let's work a couple out. So here's my chiral carbon in question. I've got a carbon here in the center. I'm connected to 4 different things: hydrogen, nitrogen, chlorine, and this bromine. So the way I like to do these, I like to redraw the sp3 carbon in question, just kind of off to the side. And since bromine is going to be my heaviest atom based on atomic weight, it gets my 1. Chlorine is the next heaviest, 2. Nitrogen, 3. Hydrogen, 4. Now remember, we need 1 on a wedge and 4 on a dash to be able to solve. They're not in that configuration, so we're going to perform 2 swaps. So I'm going to switch maybe 3 and 4. So 4 becomes 3. 3 becomes 4. And there's no wrong way to do this so long as you just do 2 swaps and you get your 1 on a wedge and 4 on a dash. So then maybe I'll switch 3 and 1 like that. And so now I've got 1 on a wedge, 4 on a dash. And I'm going to go by this new number system and not the blue ones that I drew initially. So the way you do this, you pretend like 4 is not there. And you draw a line starting from 1. And you connect the dots between 2 and 3 without lifting your pencil. And you can see that we're starting to form a clockwise circle, so this molecule is going to be R. The way I remember R from S, like the plural form of counter or countertop, counters or countertops. So if it was going counterclockwise, that would be an S, and clockwise, we're going to be an R. Let's do one more example. This one's a little tougher. I do have 2 chiral centers on this molecule. I have carbons 1 and 2. And to the untrained eye, excuse me, these would be difficult because we're just going to do carbon 2. So we're connected to a bromine, a hydrogen, and what appears to be 2 carbons. So a lot of people mistake this as being achiral, but carbons 1 and 3 are both different with respect to what's bound to them. So let's redraw the carbon in question, our sp3 configuration, 2 planar bonds, 2 3-dimensional bonds, right? And we know bromine's going to be a super heavy atom, so it's going to be our 1, and since it's on a dash bond, it's going to go right here. The invisible hydrogen is going to be our 4. Now, at the moment, we're not going to be able to determine what's our 2 pathway and what's our 3 pathway. So we're going to set up a little flow chart here. We'll call 1 a left pathway and 1 a down pathway. And here's what I mean. I'll highlight them so we can keep up. The down pathway is this one, and the left pathway is going to be this one. So we're going to go away from the chiral carbon in question, okay? So if I was to ask you, so we're looking at carbon 1, we're gonna go down that left pathway. If I was to ask you, hey, tell me everything that carbon 1 is attached to, not named carbon 2, because we're going away from it to be able to solve, you would tell me it's attached to Ca, C6, and an H. Now notice, this isn't an accident the way I wrote these, okay? You're gonna do your heaviest atom based on atomic weight at the top, down to your lightest, okay? And now we're going to ask the same question for carbon 3. So we're going away from carbon 2. We're analyzing this down pathway. And if I was to say, tell me everything that's attached to carbon 3, not named carbon 2, you would say, oh, it's carbon 4, and it has 2 hydrogens. And so what we're going to do is we're going to look at each one of these individual rows, and starting from the top, and we're going to analyze the first degree of difference. It's not going to be in our top row because we have the same element on both sides of the column. We have carbon on the left as well as the down pathway. So this doesn't help us. So when you have the same element, you just go down to the next row. And so here we encounter our first degree of difference. Carbon is a heavier atom based on atomic weight than hydrogen. So that means the left pathway is going to be our 2 pathway, and the down pathway is going to be our 3. So now we've got our atomic weights prioritization system, and 1 and 4 are out of place. So maybe we'll swap them first. So 4 becomes 1, 1 becomes 4. Now this is where a lot of students mess up because we now have 1 and 4 where we need them to be able to solve this. But remember, the rule says if you're going to do 1 swap, you must do 2. So maybe we'll switch 2 and 3. So 2 becomes 3 3 becomes 2. And we're going to go by our new number system, pretend like 4 is not there. Start with 1, go to 2, go to 3. And you can see we're starting to form another clockwise circle. So, ergo, we have another R molecule. If you found this video helpful, but you want to see more in-depth explanation and maybe some more practice problems worked out, you can find the full-length version over at orgogo.com. Please like, comment, and subscribe to help our videos find more students like you, and tell a friend. And if you're interested in private tutoring, or if you want to see a concept explained that you don't see on our YouTube page yet, shoot me an email at orgogo@yahoo.com.